Hey guys, Mr. Brown here. I hope you're all doing well. Welcome to week 2 of the pandemic of the coronavirus. So at this point in the game, we finished up with redox, unit number 8. We took the unit tests, we finished up electrolytic cells, and we're going to move forward. We're going to do unit number 9. We're going to start acid, bases, and salts. So last week on Friday, I assigned topic number 1 for Arrhenius acid and bases. Hopefully you had a chance to go through and do the notes for that, all for Arrhenius acid and bases. Again, this is the guided note packet. Hopefully you did that section of notes for Arrhenius acid and bases. Your agenda for today for topic number 2 starts on page 4. It should be actually topic number 2, not 3 there. That's a typo. Please fill out the notes for topic number 2. You could use your the link that's on Google Classroom or the slides that I provided for you guys as well. So please fill out those first and then watch the videos as well. So here's a unit packet. We did topic number 1. Hopefully you had a chance to do topic number 1 questions. Topic number 2 we're going to work on today for a little class session. Before I get to that, I do want to go through this little chart that I made. I put in the guided notes as well. Clear that up a little bit. So there's two main chemists that they like to focus on the reagents. One of them is going to be Arrhenius. The other one's going to be Bronsted-Lowry acid bases. So you should definitely be aware of the concepts and the theories in which they contributed for acid and bases. So the first one, Arrhenius. Arrhenius acids, they involved an H+, or that was a hydronium ion. The base was going to be the hydroxide or the OH- ion. This is my hydroxide. The hydroxide ion. Notice the H is negative here, the H is positive for the acid. That's the key difference there. For the Bronsted-Lowry theory, it's referring to the H+ or the proton, P+. So H+ or the P+ donor for the acid, one that donates the H+, so the proton or the H, is going to be the acid. And the one that accepts the H+ or the P+ is going to be the acceptor, is the base. Hopefully you got that from the notes or the videos. Hold on to that for the questions we're going to see on topic 2. Alright, so topic 2, let's do a few questions here. We'll probably do questions 1 through 6. Alright, starting off, question number 1. According to the Bronsted-Lowry theory, an acid. So according to the Bronsted-Lowry theory, an acid, go back to that little key that we have there. Red's the acid. An acid's going to be a proton donor. There you go. H donor, proton donor. Acid's going to be a proton donor. Must know that concept. First one's A. Number 2, what are the two Bronsted-Lowry acids in the reaction shown? So here you go. This example, I'd like to go through it. First off, I would identify the reactant to the product and which elements, compounds, are similar from the reactant to product. So HPO4 is most similar to what in the product? It's most similar to this guy right here. So first thing I would do is match these two together. So that's going to be definitely paired up with that. Why? Because they look very similar to each other. So those two are going to be similar to each other. They're going to be connected. They're called the Bronsted-Lowry pair. These other two, H2O changes to H3O. It's a difference of one H. So that H2O is very similar to H3O. Those are paired up together as well. So now referring back to an acid. So again, Bronsted-Lowry acid. What's an acid? Acid's going to be a proton or an H donor. So we're looking for which one's going to be donating. So here we go. HPO4 to PO4. What's going on? From here to here, it's donating an H. So from here to here, it lost an H. That transition, that HPO4 is donating it to something else. Where does that H go? It goes from HPO4 to H2O. So that H really just migrates, donating from here to here. Transfers from there to there. That's a donation. This donates. That has to be an acid. So it's got to be HPO4. Can't be these two. H2PO4 is not there. HPO4, excuse me, is not there. Now let's look at the product side. PO4 goes to HPO4. Okay. So it's going to be, this is going to have to gain one to the other side, the reverse reaction side. H3O goes to H2O. What's going on from product to reactant? This guy's going to have to donate a proton, donate an H to the other side. So from here to here, it lost an H. So in this situation, one of these H's are going to migrate over. It's going to donate. This PO4 is going to accept. The donation, that right there is a donation. Donation of an H is going to be an acid. So again, which one's donated? HPO4 and H3O. Best answer is B here. Let's do one more example. Number 3, what is a conjugate acid-base pair in the reaction? So again, figure out which two are most similar. So you have H2O is most similar to what on the product side? So H2O is most similar to, right there, H3O. It's a difference of one H. Those two are paired up together. The other ones, HI, hi, how you guys doing, is most similar to I. So those are the two pairs. The two blues are a pair, the two reds are a pair. Best answer, hi and I. Choice C. And let's go through one more. Number 4. In the reaction, NH2 minus plus H2O yields at equilibrium NH3 plus OH minus. Two Bronsted acids are what? So again, the first step is figure out which two are most similar from the reactant to product side. So here we go. Let's match them on up. NH2 is most similar to what in the product side? NH3. So those two are paired up together. The H2O is most similar to the OH. Those two are paired up together. Again, we're trying to figure out which ones are two Bronsted acids. Two Bronsted-Lowry acids. So NH2 goes to NH3. What's going on? From here to here, you're gaining an H. Where does that H come from? Has to come from here. So this guy is going to have to donate an H. So again, this guy donates one of these H's to go right there. This donates one to make NH3. This accepts. That donates. So again, this one's going to donate. This one's going to accept. Let's look at the product side. From NH3 to NH2. What's going on? You're going to lose an H. One of these H's is going to be lost. So you lost an H to the product, went the reactant side. Where does it go? It's going to have to go to the OH. Again, this guy donates, he accepts. Donates, accepts. Go through that process. We have an acceptor, donates, acceptor. Again, back to the beginning, we said the donors for Bronsted-Lowry are going to be my two acids. So find the ones that donate. So we have H2O